NASA's November 19, 2025 press conference quickly became one of the most anticipated and highly discussed scientific events of the year, largely because the arrival of Comet 3I/Atlas had already generated a mixture of curiosity, confusion, and wild speculation all over the internet. In the weeks leading up to the official briefing, countless social media posts circulated claiming the object was artificial, a disguised alien spacecraft, or even a cosmic warning. Hashtags trended, conspiracy pages exploded with theories, and millions of people waited anxiously for NASA to finally speak. As the conference began, Associate Administrator Amit Kshatriya addressed the public directly, making it absolutely clear that the object is indeed a natural comet, rare because it comes from outside our solar system, but still governed by the same physics and chemistry as the comets we already know. He emphasized that nothing in the collected data suggests anything artificial or extraterrestrial. That initial clarification immediately shifted the tone, allowing the rest of the presentation to focus on the extraordinary scientific opportunity that 3I/Atlas provides rather than speculation. NASA then shared a series of new images gathered from multiple spacecraft scattered across the solar system, showcasing how remarkably coordinated the global scientific community has become when faced with a rare interstellar visitor. Among the first missions to capture the comet was the Lucy spacecraft, currently on its long journey to Jupiter's Trojan asteroids. On September 16, 2025, Lucy caught a faint, fuzzy glimmer of Comet 3I/Atlas from a distance of around 240 million miles, marking one of the earliest space-based detections. Although the image appeared small and blurred to the untrained eye, it held tremendous value for astronomers because it allowed them to track the comet's brightness and approach long before it neared the inner solar system. Even more impressive were the images from the Mars Reconnaissance Orbiter. On October 2, 2025, MRO's powerful high-rise camera, normally used to photograph the Martian surface in incredible detail, captured a ghostly white smudge representing 3I/Atlas from just 19 million miles away. This made MRO the closest spacecraft to the comet during its rapid swing past Mars. The image, while still subtle, gave scientists valuable data about how quickly the comet was shedding dust and gas as it heated in the sunlight. At the same time, another Mars mission, MAVEN, turned its instruments toward the comet to analyze its spectral signature. By studying the wavelengths of light emitted from 3I/Atlas, MAVEN helped determine its chemical composition. The presence of strong hydrogen signals suggested the comet contains familiar materials, such as water ice and organic compounds, indicating that even though the comet was born around another star, the building blocks of its formation are not dramatically different from those found in our own solar system. Meanwhile, as the comet approached the Sun and became difficult for Earth-based telescopes to observe, the SOHO spacecraft stepped in. From October 15 to 16, 2025, SOHO captured a bright cream-colored point of light near the Sun's intense glare. These images are crucial because comets often undergo their most dramatic transformations during solar passage. The intense heat can cause fresh jets to erupt, dust to blow outward in massive streams, and the surface to crack or fracture. SOHO's images allowed scientists to watch these potential changes in real time. Around the same period, NASA's Punch mission produced a striking animation using data collected between September 28 and October 10. In this animation, the comet appears as a bright moving object gliding across a field of streak stars, each streak marking a distant star blurred by the spacecraft's motion. In a few frames, the planet Mars appears as a bright neighbor to the comet, highlighting how close 3I/Atlas passed to the Martian region during its journey. The animation not only revealed the comet's trajectory, but also its varying brightness, helping astronomers model how much material the comet was shedding into space. In addition to NASA's spacecraft, talented astrophotographers from around the world contributed their own observations. Shortly after the comet passed its closest point to the Sun on October 29, 2025, well-known comet photographers Michael Yeager, Gerald Riemann, and Enrico Prosperi captured high-resolution images showing multiple jets bursting from the comet's nucleus. These jets, caused by sunlight heating ancient ices inside the comet, provided breathtaking visual evidence of the comet's activity. Their photographs, shared on the ICQ Comet Observations page, became instantly popular among astronomers and casual skywatchers alike, revealing long streams of dust and gas stretching outward like luminous wings. Their images confirmed that the comet survived its solar encounter and remained active, shedding new layers of material that had likely been frozen for millions of years deep inside the comet's core. Around the same time, the European Space Agency's Trace Gas Orbiter used its CASSIS instrument to capture its own series of images from around 20 million miles away on October 3, 2025. These images, when combined into an animated sequence, showed a small, slightly fuzzy white, drifting among streaked star backgrounds created by the long exposure times needed to capture such distant light. Although the comet appeared tiny, the observations were incredibly valuable for understanding how the comet's coma, its surrounding cloud of gas, was expanding as it heated. Together, these spacecraft images, animations, and ground-based photographs created the most complete observational dataset ever recorded for an interstellar comet. Unlike Oumuamua and Borisov, the two interstellar objects previously detected in our solar system, 3I/Atlas was spotted early enough that scientists had time to mobilize multiple missions to track it simultaneously. For the first time in history, an interstellar object has been observed by Earth-orbiting satellites, Mars-orbiting spacecraft, deep space probes, and amateur astronomers across the globe. An unprecedented scientific collaboration built around a cosmic visitor from another star. During the press conference, scientists emphasized repeatedly that everything observed about the comet suggests natural behavior. Its jets, its spectrum, its path, and its response to sunlight are all consistent with what happens when frozen material heats up and sublimates. The comet's interstellar origin does not make it unnatural. Rather, it makes it a precious sample of another star system's ancient history. 3I/Atlas is essentially a wandering relic from a distant planetary nursery. It may have been ejected during the chaotic early formation of its home system, traveling in darkness for millions of years before being captured briefly by the sun's gravity. Now that the comet has passed its closest approach to the sun, it is visible again in Earth's eastern pre-dawn sky for those with powerful telescopes, offering astronomers another chance to observe it before it begins its long escape back into interstellar space. Scientists hope to track it for as long as possible, analyzing how its brightness fades, how its tail evolves, and how rapidly it loses material as it moves away from the sun's warmth. Each observation helps build a clearer picture of what interstellar comets are made of and how they behave. Every detail, from the way its jets flare out to the speed at which its coma expands, adds invaluable clues. Eventually, 3I/Atlas will disappear into the distance, becoming once again a tiny traveler in the vast darkness between stars. But the information gathered during its brief visit will remain a scientific treasure for decades to come. The data will help researchers compare our solar system with others, examine how common certain elements are across the galaxy, and understand whether planet-forming processes are similar everywhere. The conference not only dispelled rumors, but also reignited global fascination with astronomy, showing how moments like this, when a mysterious object from another star system passes silently through ours, remind humanity just how vast, interconnected, and awe-inspiring the universe truly is.